For the lesson on linear inequalities in two variables, we have the following learning targets. First, I can illustrate a linear inequality in two variables, and the second is I can determine the solutions of linear inequalities in two variables by graphing. Let us first define what a linear inequality is. It is an inequality that can be written in one of the following forms. We have ax plus by plus c is greater than c, ax plus by is greater than or equal to c, ax plus by is less than c, or ax plus by is less than or equal to c, where a and b are not both equal to 0. Okay? Then, the solution of a linear inequality in two variables is an ordered pair that produces a true statement when the values of x and y are substituted into the inequality. The graph of an inequality in two variables is the set of points that represents all solutions to the inequality. It divides the coordinate plane into two halves by a boundary line where one half represents the solutions of the inequality. Let's have an example. Say, let's graph y is less than x plus 4. Okay. So first is, we have to determine the boundary line. The boundary line is the equivalent equation. So we have y is equal to x plus 4. Okay. So let us determine the slope first of the boundary line, that is m is equal to 1, and our y-intercept is 4. Okay. Since this is 1, it means 1 over 1, we can go up 1 unit and go down, go right 1 unit. And then if we want to go down, then its pair would be, it would be paired to left. Okay. So 1 unit up, 1 unit to the right, 1 unit down, and 1 unit to the left. Okay. So our y-intercept is 4. Let's plot first the y-intercept 4. Okay, it's found here. And then we have 1 unit up and then 1 unit to the right. Okay. Then 1 unit down, then left, down, left, down, left, down, left. Okay, down, left, down, left. Okay, up, right. Okay, and then connect the points. Okay. But since our inequality is less than, mean to say, the points lying on this line are not included. So instead of drawing a solid line, let's draw a broken line or dashed line. Okay. So let's erase this one. So we have it here. We have 1. Okay. Okay. So we have now the dashed line. Okay. Now, which part of the plane is the solution to the inequality y is less than x plus 4? Okay. So let us test a point on the upper part of the boundary line. Okay. Say we have here -3 and then we have +3. Okay, let's check if this will be our shaded region or not. Okay, so we have now go back to the inequality y is less than x plus 4. Okay, so we have our y is 3 and our x is -3. So -3 plus 4. 3 is less than 1, and that is false. So meaning to say, this is not the solution, or this part of the plane, this half plane, is not the solution to the inequality. Let us try the points below this plane. So we have here point with coordinates -1, +1, okay? Then we have here y is less than x plus 4, okay? Then we have here y is 1 is less than -1, that is our x, okay? Plus 4, so we have 1 is less than 3, and that is true. So mean to say, this will be our shaded region, okay? Now, why is it that, okay, why is it that the points lying on the dashed line cannot be a solution to the inequality? Let's try one of the points here. Say we have here the y-intercept 0, 4. Okay. So we have here y is less than x plus 4. Okay. So we have here our y is 4. That is 4. Less than our x is 0 plus 4. So 4 is less than 4. And that is a false statement because 4 must be equal to 4. So therefore, the points lying in the boundary line are not the solution. Okay. So for a clear explanation of this, let's have the clear graph of y is less than or x plus 4. If you're going to input this in GeoGebra, this will be generated, okay, in which the shaded region is the lower part of the boundary line. The points in the shaded region are the solutions of y is less than x, okay? Now y is the shaded region. We can test one of the points, okay? So we have found out that the points lying on this lower part of the half plane is are the solutions to the inequality. Okay. Next. So this point is a solution to the inequality since it lies in the shaded region. So there are infinitely many points that can be a solution to this inequality as long as these points lie in the shaded region. Now, this is what we call our boundary line. The boundary line is y is equal to x plus 4. The boundary line is dashed when we have the inequality less than. And then we have here the points lying in the dashed line are not solutions of the inequality. So -2 and so the point with coordinates -2, 2 is not a solution. Okay? We can verify it again by substituting the values in our inequality. So we have our y is 2 less than our x is -2. That is our x, -2 plus 4. 2 is less than 2, and that is a false statement. That is why the points lying on the dashed line are not solutions to the inequality. Same is true with this point that lies outside the shaded region. Okay. Now, I'll be making use of the same terms x plus 4 and y, but we will just be changing the degree of inequality. Say we have here the graph of y is less than or equal to x plus 4. Comparing to the previous one in which the boundary line is dashed, okay, you can now see here that the boundary line now is a solid line. Why? Because this time, okay, the points lying on the line are included in the set. That is because of the symbol equal, okay, or because of the equality symbol. So here the boundary is y is equal to x plus 4 and the boundary line is solid. Take note of that. And the points lying here are solutions. So we can verify that by substituting the values of x and y in the inequality. Okay, so our x is -2 and our y is +2 plus 4. 2 is less than or equal to 2, and that is true. 2 is less than or equal to 2. Okay, this means 2 is less than or equal to 2. So that one of the statements is true, so that is true. Okay? So mean to say, when the inequality is less than or equal to, the boundary line is a solid line. And of course, the shaded region lies in the lower part of the boundary line. So, we'll have now the graph of y is greater than x plus 4 and y is greater than or equal to x plus 4. Notice that we have the same boundary lines, okay, but we only differ with the shaded region. As you can observe, the shaded region for the inequality greater than can be found on the upper part of the boundary line. Same is true with y is greater than or equal to x plus 4. The only difference is that the boundary line is a solid line. So take note that when the boundary line is dashed, mean to say the points lying on the broken line or dashed line are not solutions to the inequality. Whereas here, y is greater than or equal to x plus 4, which is a solid line, the points lying here are part of the solutions to the inequality, of course, including the points lying on the shaded region. And the points lying outside outside the shaded region are not solutions. To sum up everything, okay, the graph of y is less than x plus 4 and the graph of y is greater than x plus 4, okay, they have the same boundary line, which are both dashed, but they only differ in the shaded region. If the inequality is less than, the shaded region is found on the lower part of the boundary line, and if the inequality is greater than, the shaded region is found on the upper part of the boundary line. Okay, and take note that again, the solutions lying on the dashed line are not solutions to the inequality. And to compare the graph of y is less than or equal to x plus 4 and y is greater than or equal to x plus 4 is the same as that of these graphs. The only difference is that we have here solid lines, okay, in which it only indicates that the points lying on the solid line are solutions to the inequality. Okay, again, if the inequality is less than, the shaded region is found on the lower part of the boundary line, and if the inequality is greater than or equal to, okay, then the shaded region is found on the upper part of the boundary line. Okay, so I think it's clear now. Let's have another example. Say you are asked to compare the graphs of 2x plus 4y is less than or equal to 8 and 2x minus 4y is less than or equal to 8. Let us first simplify h before graphing. Okay. So let's start with 2x plus 4y is less than or equal to 8. So we're going to write each in the slope-intercept form. So in the graphing part, it will not be difficult for us. So we are going to apply here the subtraction property of inequality. So we have here negative 2x plus 8. Then we have here 4y. Then dividing all terms by 4. Okay. So you have y is less than or equal to negative x over 2. That is because the common factor of 2 and 4 is 2. So the 2 divided by 2 is 1, or negative 2 divided by 2 is negative 1. When the coefficient is negative 1 or 1, we did not write the 1 number anymore. 4 divided by 2 is 2. Then we have 8 divided by 4 is 2. So mean to say here, our boundary line equation is y is equal to negative x over 2 plus 2, where our slope is equal to negative 1/2 and our y-intercept is equal to 2. So if we have a slope of negative 1/2, it means we have the combination of 1 unit up and then 2 units left. Okay, then or we could have if we have down here, okay, down, 1 unit down and 2 units to the right. Okay, 1 down, 2 units to the right, 1 up, 2 units to the left. Okay, Let us plot first the y-intercept, and that is 0, 2. Okay, it's found here. Then we make use of the slope to determine other points lying on the line. So we have negative 1, 1 up, 2 to the left. Okay, 1, 2. 1 up, 2 to the left. 1 up, 2 to the left. Okay. Then going down, then 2 units right. 1, 2 units to the right. 1, 2 units to the right. Since we have here less than or equal to, then we have here a solid line. Okay, because of the equality. Okay, involved in the inequality. Okay, so we have here a solid line, and since this is less than, then the shaded region must be found on the lower part of the boundary line. Okay, this is it. This is now the graph of 2x plus 4y is less than or equal to 8. Now the question is the graph of this inequality be equal to this inequality, 2x minus 4y is less than or equal to 8? Since, as you can see, all the terms are the same except for the plus and minus here. So let's find out. So we have simplified 2x minus 4y is less than or equal to 8. So we're going to write this one in its slope-intercept forms, just like what we did in the previous inequality. So applying the subtraction property. So we have negative 2x plus 8. Okay. Now dividing all terms by negative 4, negative 4. So we have now y is. Okay. Now what will happen to the inequality when both sides of the inequality will be divided by a negative? Okay. Always remember that when you divide both sides of the inequality by a negative number, the degree of inequality will change. So from less than or equal to, it becomes greater than or equal to. Take note of the changes. Okay? So then we have here negative 2 divided by negative 4. Of course, that is 1/2. That's we have here x over 2. Then we have 8 divided by negative 4 is equal to negative 2. So our boundary lines equation is y is equal to negative of x over, positive x over 2 minus 2, where our slope is equal to 1/2. Okay, it's different now from the previous equation's slope, which is negative 1/2, and our y-intercept is negative 2. So we have here the combination of the movement. So we have 1 unit to the 1 unit up, then 2 units right, or 1 unit down, then 2 units to the left. Okay, so let's graph it. Let's plot first the y-intercept, which is negative 2. Okay, then we have 1 up, 2 to the right, 1, 1, 2, 1, 1, 2, 1, 1, 2, and then down left, 1, 2, down 2 units to the left, down. Okay, so since we have here now greater than or equal to, so we have a solid line in which the shaded region is found on the upper part of the boundary line. Okay, so obviously the two inequalities are different. Okay, since we have different slope, they have the boundary lines have different slope and y-intercept, and of course they have different solution sets. Okay, I hope this is clear now.